So with that, we're going to jump over to Earl, and Earl Hackett is going to jump in here. Earl's been building a bridge for his West Virginia modeling focus, and he's going to talk a bit about doing a bridge and using 3D printing. I think he's got some good news and some great modeling and some challenges as well. So Earl, I'll throw it over to you, and you've got your own slides. So
Right. Okay.
take her away.
Get this screen shared up here. Okay. So we're gonna start. I'm gonna start off with the what have I got here? Come on. There we go. The prototype. The This is the prototype. The This is a bridge over the New River at Thurman, West Virginia. It's a Warren truss and it's skewed 45 degrees across the river, and it has a single lane roadway for cars going across. It's quite a long bridge. This is 220 some feet long on the truss with a whole bunch of girder bridges on the other attached to it. This is another view showing the roadway and some of the truss details. I have very little information on the actual truss. They have a lot of information on the girder part, which is pretty easy to build. But originally, this bridge consisted of 3 truss bridges. I'm not sure what kind they were, but there were 3, and the old piers are still there. I underline those in red. The new truss went on to a concrete pier here. The old piers are all stone block construction. Now, I only have 6 feet available, so I basically have lopped off 3 of these trusses here, and that so it fits. But I wanted to keep the truss structure here full scale. I didn't want to mess with that at all. This is about the only dimensions I have for it. The roadway is 10 feet wide. The center lines on these main trusses are 17.6. And that's about all I had. But I was able to pretty much scale the rest of it off from looking at photographs and everything. We wound up building a little wireframe showing just center lines. Really not much useful in modeling, but overall it allowed me to pretty much lay out how the bridge was going to fit into the. Now, one of the things I found was that the railroads all use the same dimensions. These are standard girder bridge dimensions. The girder bridge, you have stringers inside those trusses, which are actually a girder bridge. They call them stringers when they're put in a girder bridge. But those, all in my layout, on that bridge, they're all 30-foot long. So I'm using a 5'9" stringer with and the floor beams, which are what go across the perpendicular to the stringers. Those are 6 feet. And I was able to actually measure those on the bridge. But what they'll do is if you go over 30 feet, you go up to the next size panel. So anything from 30 to 50 feet long will be a 6.5 foot high girder. From 50 to 70 feet would be an 8-foot girder, and so on. This is the what I call the core drawing of it. None of the detail is shown. These are just flat surfaces that illustrate where things are going to go. These are the supports for the roadway over here, and these are the various beams and girders and such. The basic bridge is built around a machined wooden core, and this wooden core provides the primary strength for the structure. Now, they gave me all kinds of dimensions for the piers. They went crazy on it. They had measurements for every doggone thing you can imagine, and they also had the elevations. So I was able to make pretty good drawings of 3D models of these and print them out. They have a This one is one of the older piers. It has a stone block construction, and the others are all poured concrete. So this is all pretty basic 3D printing. Now we're getting into the real construction. This is actually the third attempt I've taken at building this bridge. The others failed for one reason or another. I won't go into that. Some of it's rather embarrassing. But what I would have to do, I have to build my own ties because they're all custom length. And for that, I'm using a thickness sander. This is a Burns Model Machines thickness sander. And it's one of the handiest things I've got because I make my own strip wood out of this. In this case, I'm sanding a piece of that is probably poplar, sanding it down to form for the thickness of the tie thickness. And this thing you can adjust it to plus or minus about 1/1000th of an inch. It's a very accurate machine. When it's running this fume hood here, that sits up on top, and otherwise the dust is incredible. This is the core piece. This is the core of the bridge. These marks show where the floor beams are going to be, the approximate location. It's just a piece of 3/4 inch pine. And when I would cut it a little bit wide on my bandsaw, and then I started feeding it through the thickness sander until it got down to exactly the thickness I wanted. This has to be held pretty darn tight. I think it was 20 millimeters plus or minus 1/10 of a millimeter or so. So this whole 6-foot piece went through the sander, sanded it down, and it's dead straight. This over here is a tie jig. Ties on a bridge are much, much closer than the ties on regular track. So this is a 3D printed tie jig. This is this is my little table saw. This is also a Burns auto machine table saw. You notice over here we have a micrometer. I can adjust this fence to within 1/1000th of an inch before I want it. And for some operations, that becomes really, really necessary. So when I'm making ties, I'll sand them to thickness, and then I have a gang saw that I set up, and this cuts them to width. So the distance between these various slitting saws is the width of the tie. You pass the thing through here. I have a piece of wood that's just clamped in there. So the wood, the married pier you're cutting just doesn't push away from it. And you just pull it through, and then you wind up with this. Piles of, 5 foot, 4 foot long strips of tie material. When I go to cut them down to thickness, I put them on my little auto machine, my little table saw, and I'll set them up for about 5x5 set of them. So there's about 25 in a stack, and each pass through the blade to get 25 ties. Now we have 3 different ties. I have 2 different ties that I'm going to use. This is the size of your normal railroad tie. This is a bridge tie. It's a little bit longer than this because you're going to put guard timbers out here. This bridge didn't have guardrails on the inside, but they used guard timbers on the outside to catch anything that got off the track. Now, about every fourth space between ties, they would put in a 2x8 piece of treated lumber, and that would be the support for the walkways on the side. I thought that was a pretty wimpy structure, so what I've done, I just cut the tie this tie a little longer, and I take the end down so it wind up with a 2x8 inch tip, and you can't see anything else. So it looks like you have a 2x8 piece of wood sticking out there. So again, this is their tie. It's a little warped, but okay. Now when I'm putting it down, ties will go in 3. This is a space left for one of those long ties to fit in later on. So I'll do one tie section, small sections like this. And one of the problems you're faced with, you have to have these ties dead center on that piece of that wood core. They can't be off by anything. So on my table saw, I made 2 sets of spacers. One is for the regular bridge ties, and this is for the long ties. You can see this steps out a little bit further. You basically put this edge here against the core and slide the ties over until they butt up against it and glue them down. This shows it in use. I keep the what I've done. I've put narrow strips of blue tape on the sides. They're far enough apart so that when I glue it down, once the glue sets up, pull this off and just strip them off, and they're all set up nice and in alignment. Putting in the long ties. This is done by hand. Just leaving a space. Leave a space where the bridge floor beam is going to go across. That'll be that would just be a piece of plastic that I stick in there. But they'll still go in. Gluing these things in is a little. I use this. These are the handiest little glue bottles you can possibly imagine. They're maybe a 5 or 6 cc bottle. Amazon will sell them like I got 100 of them for, I think it was $10 or $12 or something like that. They're ridiculously inexpensive, and I use them for just all sorts of liquid glues. But here you have the ties are all in place. They're all centered up. Now the trick is getting the rails centered up. The rails have to be centered on there too. And so what I did, I 3D printed a bunch of these little guys. This holds the base of the rail, and I slip them down in between these ties and glue them in place. They're glued in place with a jig that looks like this. It's 3D printed, and it slips over those long ties, so it can slip in here. You butt it up against this, and eventually you'll use this to position the rails and either glue them down or spike them. And this would be the wood core. So finally, we get around to putting down the rails. Initially I glued them down with what is this stuff? Plyo-Bond. Yeah, Plyo-Bond. And again, the Plyo-Bond was in one of these little squirt bottles. And my previous layout, the bridge was glued down with Plyo-Bond, and it lasted for 20 years until I tore it up. But I wasn't able to use it the way I did there. What I did before was put it on, let it dry, hold the rail in place, and then just run a soldering iron down and melt it, and it glue it together with the heat. This is so long that I was afraid that I'd have a problem with metal expansion, and I couldn't predict what was going to happen. So I glued it down, let it get tacky, and glued it down. I didn't trust it, so I went back and put spikes on every 6th or 7th tie. And so we're ready to start getting to put it into position. This is where it'll go. It goes very close to the freight house. And so there we have it. This is where we're going to quit for today. Next week, I'm going to be mounting the girders on the bridge, the girders, the girders, but the girders. Going to mount the bridge on the piers, and we'll start building the walkway. Build the walkway once it's on the piers and on the layout, then I'll build the walkway because it's going to be very, very delicate, and trying to move it around with the walkway on there would be suicidal. Okay. And share. Stop sharing. All right. Anybody have any questions?
That was excellent, Earl. It was interesting using the block of wood. I actually did a similar kind of longer bridge and used a piece of angle aluminum angle that I found at Home Depot. So, but you do have to have something in the core for strength. That's really important.
Yeah.
So,
Yeah. I'll maybe before I'm down, one of these times I'll show the methods that failed because you don't want to repeat that.
that would be good.
Yeah.
I like the one of the clinics that they do at the National NMRA convention is done by the LD SIG group, layout design folks, and the
Mhm.
name of the clinic is called Only Make New Mistakes. So I think it's a
Yeah.
good idea. I mean, knowing the things not to do is almost as important as knowing the things to do. So
Right.